Hello, in this video, DRAM operation is continued. After the write operation is completed, the write access transistor M1 is turned off. With the storage capacitance C1 charged up to a logic high level, transistor M2 is now conducting. To read this stored one, the read select signal RS here must be high. As the read access transistor M3 turns on with this RS signal, M2 and M3 create a conducting path between the data read column here, C3 capacitance, and the ground. The capacitance C3 discharges through M3 and M2, and the falling column voltage is interpreted by the data read circuitry as a stored logic 1. For the write 0 operation, the inverse data input is at the logic high level because the data to be written onto the DRAM cell is now a logic 0. Consequently, the data write transistor is turned on and the voltage level on column data in here is pulled to logic 0. Now the write select signal is pulled high during the active phase of V2. As a result, the write access transistor M1 is turned on. The voltage level on C2 as well as that on the storage node C1 is pulled to logic 0 through M1 and the data write transistor here. So at the end of write 0 sequence, the storage capacitance C1 contains a very low charge and the transistor M2 is turned off since its gate voltage is approximately equal to 0. To read this stored 0, the read select signal RS must be pulled high during the active phase of V2 following the precharge cycle. The read access transistor M3 turns on, but M2 is off because voltage at this node is 0. So C3 does not discharge and the logic high level on this data out column is interpreted by the data read circuitry as a stored 0 bit. To summarize, the drain junction leakage current of the write access transistor M1 is the main reason for the gradual depletion of the stored charge on C1. To refresh the data stored in DRAM cells before they are altered due to leakage, the data must be periodically read, inverted, and then written back into the same cell location. This refresh operation is performed for all storage cells in DRAM array every 2 to 4 milliseconds. We can see that this 3-transistor dynamic RAM cell does not dissipate any static power for data storage since there is no continuous current flow in the circuit. Also, the use of periodic precharge cycles instead of static pull-up further reduces the dynamic power dissipation. The additional peripheral circuitry required for scheduling and non-overlapping control signals and the refresh cycles does not significantly overshadow these advantages.